Okay, so we're going to do lesson 2, generating equivalent expressions today. We're going to see how using addition and multiplication, using our knowledge of the commutative and associative property can help us generate equivalent expressions. We know that adding a negative and subtracting are the same thing. So we're going to take that knowledge that we have and apply it to expressions. The same thing as whenever we're doing division. Division is the same thing as multiplying by the inverse. So we're going to use those. And lastly, we're going to see that any order does not apply for expressions that involve both addition and multiplication. We're going to need to make sure that we follow the order of operations in that. So let's start with our opening exercise here to get us going. It tells us that our expression is 1, and so you need to notice that the opposite of -1 would mean that if they are truly opposites, then together they'll give us 0. Let's do the next one, 3. The opposite of 3, -3. To prove that they're opposites, 3 plus -3. We're to the right on the number line 3 units. We go to the left 3 units since it's negative, and we'll get that 0. But what if we have a -7? What is the opposite of -7? +7. To prove that they are opposites, if we put a -7 and a +7 together, we'll get 0. Can we do the same thing with fractions? Absolutely. If we have a -1/2, we would pair it with a +1/2. So to prove they're opposites, -1/2 plus +1/2 would again give us 0. But what about if we have a variable? Can the same things apply? Absolutely. We have x, the opposite of x. The opposite of a positive x would be a negative x. So the same concept as what was happening up here applies when we have a variable. If I pair an x with the opposite sign of -x, then together those will give me 0. Well, what about if I have an x, a variable of x with a coefficient of 3? What's the opposite of 3x? -3x. So if I pair those together, to prove they're opposites, I would have 3x and -3x. Again, they would cancel each other out to give us 0. Let's take this expression. What if we add 3 to x? We remember that we want it to equal 0. So if I'm going to add 3 to x, the opposite of x plus 3 is, what would we have to pair with x? -x. What would we have to pair with 3? -3. So if I put these together, if I put x plus 3 plus, like we've been doing all along here, -x plus -3, that will give me 0. It might help some of you to see it if we group like terms together. If I put my x's together, x plus -x, we already discussed up here that that was 0. And 3 plus -3, we already showed up there that that was 0. So again, a 0 and a 0 would give us 0. Well, what if our expression gets a little more complex than that? 3x minus 7. What is the opposite of 3x minus 7? We'll take each term individually. What's the opposite of 3x? -3x. What's the opposite of minus 7? I would have to pair it with a plus 7. So to prove that they're opposites, we would add them together. 3x minus 7 plus -3x plus 7. If we did what we did the step before and pair the things that are alike, the terms that are alike, 3x plus -3x, put those two together, and -7 plus 7 would both get us back to 0. So understanding that when you add opposites, they give you 0 is going to be beneficial. We took our knowledge of just one number and applied that to expressions down here. Let's keep going. So what does that mean for subtraction? Subtracting expressions. Well, you learned that when you subtract, that's really the same thing as adding the opposite. So if I have 40 plus 9 minus 30 plus 2. Well, that's the same thing as not writing minus, but write plus the opposite of 30 plus 2. I'll put another set of parentheses there to just make sure it's clear. So we just use our additive inverse property to see it differently. So what is the opposite of 30 and the opposite of 2? Our next line would look like this. The opposite of 30 is negative 30. The opposite of 2 is negative 2. So then we could combine as needed. 40 plus 9 gives us 49. What is 49 plus negative 30? Remember, you go to the right on the number line, then go to the left. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. And then we have 19 plus negative 2. Again, like we just said, different sign, so we subtract. Take the sign of the larger number, then we'll be exact. So that is positive, a positive 17. Some of you might have been tempted to do it this way, and to be honest, this is the way that I would have done it as well, but I wanted you to see that both of them work the same way. I would have done 40 plus 9, which gives me 49. Actually, I would have did parentheses first, sorry. 30 plus 2 is 32. Doing your order of operations, we would bring the rest down. Then we would do addition and subtraction from left to right. So 40 plus 9 now is 49, and 49 take away 32 is 17. So you see they are equivalent to each other. This was just using the opposite of a sum is the sum of its opposites, and this was using the order of operations. Either way works. I have a feeling the majority of you are this way. But understand that things can be proven in more than one way. So, and I believe you would agree that this one's probably more efficient. But let's try another one. Let's subtract these two expressions. So we went from numbers here to expressions here. But let's rewrite the subtraction problem as addition. And you can do that with any subtraction. So I would write 3x plus 5y. Rather than writing minus 4, I'm going to write plus negative 4. Rather than writing the subtraction here, I would write plus, and then the opposite of 4x plus 11. So the opposite of 4x plus 11. We just added the opposites. So now let's take what this means. 3x plus 5y plus negative 4 plus, well, what's the opposite of 4x? Negative 4x. What's the opposite of 11? Negative 11. And now we can combine like terms like we did last unit, or last lesson, I should say. Can we put anything with the 3x? We can. Let's put these together. Let's write 3x plus negative 4x.